On to electronic structure. Yes, you do need to remember electron configurations. That whole 1s2, 2s2, 2p6, so on and so forth, right? I put a little chart here, hopefully to help you out. Remember, they go by period, right? 1s, 2s, 3s. If you know where the S and the P and the D and the F block are, that would be super helpful. If you're in this block, remember D starts at level 3, not level 4, and then F starts at level 4, not level 6, which is the row that it's in. If you need help remembering those, I have a couple of ways to do that. You can come see me. But you should be able to figure out the electron configurations just by knowing where an element is. Shorthand can really come in handy. The shorthand is when you put the noble gas that's before it. So noble gas that's before your elements in brackets. And then it's something S2 and whatever else you need. To know which one to start at, it's the row that your element is in, or period. Row your element is in. And I'll do a practice one here in a minute, okay? That's essentially how to do the shorthand. And then when I say orbital diagrams, that's like 1s with the arrows, and we usually use half arrows. You can use full arrows if you want to. And then 2p, hold 6, so on and so forth. All right, so we're gonna write the electron configuration, noble gas configuration, and orbital diagram for iron. And I chose iron because it goes all the way to the D block, and that'll be really helpful with our practice. So, all right, iron has 26, yes. 26 electrons, unless it has a charge. If it's positive, it has a few less electrons. If it's negative, that means more electrons. Don't forget that. But I'm going to start at the beginning. I'm going to write it. 1s2, 2s2, then comes 2p. P's hold 6. Then comes 3s2. Then comes 3p, 6, 4s2, and then it's 3d. Remember the first D block is there, and there's only 6 in the D block. So your last one is not going to be full, and that's totally okay. All right, I'm going to do the noble gas configuration now. Actually, I'm going to pull up ptable.com. Okay, if you don't have a periodic table handy, I highly recommend using ptable.com. It's got everything you will need to know. Here is iron, okay, number 26. I want to find the noble gas that's before it. So you go up a row all the way to the right. Argon is going to be before iron, so that's what I'm writing on here. So I would go AR in brackets, and that takes up the first 18 of my electrons. Okay, so argon, and then to know where you start after that, it's the row your element is in. Notice I'm in number 4. Okay, the S block always. Okay, so I'm starting at 4s after that. So it's argon, and then it's 4s2, and then I needed 3d6. So that still adds up to 26. Argon's 18 plus 2 plus 6. Okay, now orbital diagrams. I got to write out this whole thing in orbital diagrams. So S's hold 2 electrons, 2s. P's have 3 orbitals, and then 3s, and then 3p, 2, 4, 6, and then 4s. And then D's have 5, so this is 3d. And remember, the electrons like to spread out before they pair up. So 1, 2, 3, 4, 5, 6. Okay, so that's Hund's rule. They like to spread out before they pair up. Okay, on to the trends, which have a lot to do with those electron configurations. Trends you'd need to remember are atomic radius. Oops, atomic radius. Okay, atomic radius goes this direction. Sorry, this is hard on this tablet. We would assume that francium or francium, however you want to say it, is probably the largest of the atoms. It hardly exists, but francium would be the biggest. So this is atomic radius. I'm going to go AR. Okay, reasoning, we're not going to get into now, but if you need help with the reasoning, let me know. All right, I'm going to change my color really quick. Atomic radius. Now we also need to know ionization energy. Now, what is that? That is the energy to remove 1 electron. Okay, second ionization energy would be the energy to remove a second, and so on and so forth. Completely opposite of radius, right? Because based on Coulomb's law, and Coulomb's law says that the smaller something is, so the closer they are, the protons to the electrons, it's more difficult to remove an electron because there's more attraction. So if it's bigger, it's going to be easier to remove an electron. And also the amount of charge. So if it has more protons, it's going to have more attraction and be more difficult to move. So that's why it's completely opposite of radius. So ionization energy goes this way. The further away they are, easier to remove. So like if this is really big, it's going to be really easy to remove an electron. Okay. Also, ratio-wise has fewer protons. Last one we need to know, let's do green, is electronegativity. Right, this is really important when we talk about polarity and things. So that's just its ability to attract an electron. Okay, so electronegativity is going to go with ionization energy, whoop, that way, and whoop, that way, except fluorine is the most electronegative element. Noble gases do not have electronegativity. They don't want any electrons. They are good. They're happy. They have a full octet. So noble gases have no electronegativity. Yeah, sure, spelled that right. So keep that in mind, no electronegativity for those noble gases. All right.